Welcome my dear learners for this course on design of machine elements 1. In our previous lecture we have started discussion on theories of failure. Continuing by recalling the discussion what we had in our previous lecture, that is on theories of failure, let us solve numerical problems on theories of failure. In our previous lecture we have solved a numerical problem on theories of failure wherein which the maximum and minimum principal stress have been given to us. It is a triaxial stress system. Moving ahead, in today's lecture, let me discuss how to determine principal stresses and how to use maximum and minimum principal stresses to determine the unknown parameter using theories of failure in today's lecture. Continuing our discussion on theories of failure, the problem number 2 states that a plate of C45 steel with tensile yield stress 353 megapascal is subjected to following stresses. Sigma x is 150 Newton per millimeter square, sigma y is 100 Newton per millimeter square, and tau xy is 50 Newton per millimeter square. Find the factor of safety by maximum principal stress theory, maximum shear stress theory, Henschke's theory. Let us solve problem number 2. If I move for solution of problem number 2, first let me list out the data given. We have specified the tensile yield stress as 353 megapascals and given the value of sigma x as 150 MPa, sigma y as 100 megapascals and tau xy as 50 megapascals. We know when sigma x, sigma y and tau xy are given, how to determine maximum and minimum principal stresses, which we have already discussed in our lecture 2 of this series. That is, if I move for solution, first in order to employ theories of failure, we should know maximum and minimum principal stresses first. So therefore, let me determine the maximum and minimum principal stresses. We know that maximum principal stress sigma 1 is equal to sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 whole square plus tau xy square. This is nothing but equation number 1.8c referring to page 5 of our design data handbook written by K. Mahadevan and K. Balavira Reddy. We are referring 4th edition. Now if I substitute and solve, I will get the value of sigma max as sigma x is 150 plus 100 by 2 plus root of 150 minus 100 by 2 the whole square plus tau xy square is 50 square. So if I substitute and solve, I will get the answer as 150 plus 100 by 2 plus root of 150 minus 100 by 2 whole square plus 50 square. The maximum principal stress sigma 1 is turning out to be 180.9. (180.902 megapascals). So this is the value of maximum principal stress. Similarly, we know how to find minimum principal stress sigma 2, which is given by sigma x plus sigma y by 2 minus root of sigma x minus sigma y by 2 whole square plus tau xy square. So therefore, the magnitude of minimum principal stress will become, just change this sign to minus, and this is also known to you people. This is equation 1.8d referring to page number 5. So change it to minus here. If I change it to minus, I will get the answer as 69.098. 69.098 0.098 megapascals is the magnitude of minimum principal stress. Now we know maximum principal stress, we know minimum principal stress. Now you can use theories of failure to determine the factor of safety. First let me address maximum principal stress theory. So if I go for maximum principal stress theory, according to maximum principal stress theory, sigma max should be less than or equal to sigma yield in tension by factor of safety, where sigma max is nothing but max of sigma 1 comma sigma 2 comma sigma 3 for triaxial system. Here sigma 3 is 0, so therefore if I observe the maximum of sigma 1 and sigma 2, sigma 1 is maximum, so therefore sigma max is nothing but sigma 1, so ultimate is equal to yield stress in tension is 353, yield stress in tension is 353 by n, so therefore if I substitute and solve, n is equal to 353 divided by 180.902. Therefore factor of safety n will be 353 by 180.902, which is equal to 1.951. So this is the factor of safety according to maximum principal stress theory. Moving for maximum shear stress theory. According to maximum shear stress theory, tau max should be less than or equal to tau yield by factor of safety, that is tau max is nothing but max of sigma 1 by 2, sigma 2 by 2, sigma 3 by 2, sigma 1 minus sigma 2 by 2, sigma 1 minus sigma 3 by 2, sigma 2 minus sigma 3 by 2. So now here we don't have sigma 3 because it is a biaxial stress system, so therefore we are left out with 3 combinations. So maximum of these 3, if I go, I'll get sigma 1 by 2 as a maximum value. So therefore tau max will be sigma 1 by 2 is 180.902 by 2, sigma 2 by 2 is 69.908 by 2, and one more is sigma 1 minus sigma 2 by 2, that is also less than 180.902 by 2. So therefore max is sigma 1 by 2, max is sigma 1 by 2, which is equal to 180.902 by 2, which is nothing but 90.451 megapascals. Now if I substitute to this equation and solve, we'll get tau max should be equal to tau yield by n or sigma yield by 2n. So tau yield is half of the sigma yield, so substituting for that, tau yield will become sigma yield by 2. So hence if I substitute and solve, I'll get the answer as 90.451 is equal to 353 by 2 into n. Hence factor of safety n for this problem will be 353 by 2 into 90.451, which is turning out to be same, that is 1.9513. From both maximum principal stress theory and from maximum shear stress theory, we got the same factor of safety as 1.951. Let us check from Rankine theory, which is nothing but distortion energy theory. Kindly make a note. Rankine theory is nothing but distortion energy theory. Rankine theory or distortion energy theory. According to this theory, we know that sigma yield by n whole square should be equal to sigma 1 square plus sigma 2 square minus plus sigma 3 square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. Now for this system we have only sigma 1 and sigma 2. This is a biaxial stress system, so therefore sigma 3 is not there and sigma 3 is 0. If I substitute sigma 3 0, this will get cancelled. So directly I can find what is the value of n by substituting the values. Sigma yield is known, that is 353 by n the whole square should be equal to sigma 1 square, that is 180.902 square plus sigma 2 is 69.098 square minus 180.9 into 69.09. So therefore factor of safety according to distortion energy theory will become 353 by alpha hex whole square is equal to 180.902 square plus 69.098 square minus 180.902 into 69.098. Shift solve is equal to, I will get the answer for factor of safety as 2.232. 2.232. This is the solution for problem number 2, wherein which we have calculated the factor of safety using these three theories of failure. Let me pause this video for a while so that you people can copy it down. Later we will address problem number 3. Now moving ahead, the problem number 3 states that a rod of circular cross section is to sustain a torsional moment of 300 kN meter and bending moment of 200 kN meter. Selecting C45 steel with tensile yield strength of 353 megapascal and assuming a factor of safety of 3, determine the diameter of rod as per following theories of failure. First one, maximum shear stress theory. Second one, distortion energy theory or shear energy theory. Third one, total energy theory or Hike's theory. Fourth one, maximum normal stress theory. Come, let us solve this problem. If I list out the data given for us in problem number 3, we have a circular rod sustaining a torsional moment of 300 kilonewton meter and a bending moment of 200 kilonewton meter. Selecting C45 steel of yield strength in tension as 353 megapascals and a factor of safety of 3, determine the diameter of the rod is the question what he is asking. Now he is also not specified the values of normal stress as sigma x, sigma y and shear stress in xy plane, that is tau xy. In these situations we should find the value of sigma x and tau xy. So for that he has specified the value of bending and torsion. So sigma x is nothing but bending stress and tau xy is nothing but torsional stress. So therefore, using bending moment, find the value of sigma x. Sigma x will become, for circular cross section, bending stress sigma b is nothing but Sigma x is nothing but sigma b, because it is subjected for bending moment of 200 kilonewton meter, which is nothing but mb by z. This you people already know. For particularly for circular cross section, you know the answer for bending stress, that is 32 mb by pi d cube. So here unit has to be in Newton millimeters, so therefore this will become, this is in meter. In order to convert this into millimeter, I should raise 10 power plus 3. So therefore here already we have 10 power 3, hence it will become 300 into 10 to the power of 6 Newton millimeter. This will become 200 into 10 to the power of 6 Newton millimeter. Kilo is 10 power 3. In order to introduce milli, I want to raise 10 power 3. Total it will become 10 power 6. So if I substitute and solve, I will get 32 into mb is 2 into 10 to the power of 8. I will take this 2 here, it will become 2 into 10 to the power of 8 divided by pi d cube. So therefore sigma x will be 32 into 2 is 64, 64 into 10 to the power of 8 by pi d cube. Let me keep it as it is. Now we got sigma x. He has not specified sigma y, so therefore take sigma y as 0, not specified. Now he has given the torque, so therefore we have shear stress tau xy. For circular cross section, we know the formula for shear stress, which is given by 16T by pi d cube. So hence if I substitute the values, it is 16 into torque is 3 into 10 to the power of 8 divided by pi d cube. Hence I will get tau xy as 16 into 3, that is 48 into 10 to the power of 3, 48 into 10 to the power of 8, 48 into 10 to the power of 8 by pi d cube. Now we got the normal stresses sigma x, sigma y and tau xy, using which I can find maximum and minimum principal stresses. Once you find maximum and minimum principal stresses, we can use theories of failure and find the diameter required. So therefore, first let me find maximum principal stress, that is sigma 1, which is equal to sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 whole square plus tau xy square. This is nothing but equation 1.8c, referring to page number 5 of our design data handbook written by K. Mahadevan and K. Balavir Reddy. We are referring 4th edition. So if I substitute the values and simplify, I will get sigma 1 as sigma x is 64 into 10 to the power of 8 by 2 pi d cube plus, because sigma y is 0, plus root of 64 into 10 to the power of 8 by 2 pi d cube whole square plus tau xy is 48 into 10 to the power of 8 by pi d cube whole square under the root. Now if I take 10 power 8 by pi d cube common, sigma 1 will be 10 power 8 by pi d cube. If I take common, it is 64 by 2, that is 32, plus here it will become root of 64 by 2 whole square, that is 32 square plus 48 square, which is nothing but 57.69. 57.69. So therefore sigma 1 will be plus 32, which is nothing but 89.689 into 10 to the power of 8 by pi d cube. Clear? Now if I find minimum principal stress, that is sigma 2 will be sigma x plus sigma y by 2 minus root of sigma x minus sigma y by 2 whole square plus tau xy square. So if I do that, I'll get the same equation with negative sign here. So hence sigma 2 will be 10 to the power of 8 by pi d cube times 32 minus 57.69. Hence sigma 2 will become 32 minus 57.89, 57.69, which is nothing but minus 25.69 into 10 to the power of 8 by pi d cube. Now we have determined maximum principal stress and minimum principal stress. Hence we can use the theories of failures and define the diameter. If I go for first one, that is maximum shear stress theory, that is from maximum shear stress theory we know that tau max should be equal to sigma yield by 2 times factor of safety, because tau max should be less than or equal to sigma yield by factor of safety, where tau yield is sigma yield by 2. Tau max should be less than or equal to tau yield by factor of safety, where tau yield is sigma yield by 2, substituting which tau max will become sigma yield by 2 times factor of safety. And from theories of failure we know that the tau max is nothing but maximum value of sigma 1 by 2 or sigma 2 by 2 or sigma 1 minus sigma 2 by 2. So if you carefully observe, maximum principal stress is positive, minimum principal stress is negative, hence minus of minus will become plus. So therefore I will get sigma 1 minus sigma 2 by 2 as maximum value. So therefore tau max will be sigma 1 minus sigma 2 by 2. Hence the equation will reduce to sigma 1 minus sigma 2 by 2 should be equal to sigma yield by 2 times factor of safety. So if I substitute and solve, I'll get the answer as 89.689 plus 25.69, which is nothing but 115.379. 115.379 into 10 to the power of 8 divided by 2 times pi d cube. This must be equal to sigma yield by 2n. Sigma yield is 353 by 2 into 3. Factor of safety is 3. Sigma yield is 353. Now if I solve, I'll get the answer as 115.379 into 10 to the power of 8 into 6 divided by 2 into pi into 353. So cube root of answer will become 314.85. So hence adopt D is equal to 315 millimeters. So according to maximum shear stress theory, we got the diameter as 315 millimeters. Moving ahead, second one is according to distortion energy theory. According to distortion energy theory, we know that sigma yield by n whole square should be equal to sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. So if I substitute and solve, sigma yield is known, which is 353 by 3 whole square should be equal to, let me take 10 to the power of 8 by pi d cube square common. I left out with 89.689 square minus 25.69 square minus of minus will become plus 89.689 689 into 25.69. So if I solve, I'll get the diameter as 89.689 square minus 25.69 square. So plus the whole square, here it will become plus sigma 2 whole square. So when I whole square it, minus of minus will become plus. Then sigma 1 into sigma 2, minus of minus will become plus, correct? So I should use plus here. Then I should use plus 89.689 into 25.69. How much is this? This is multiplied by 10 power 8 square into 10 to the power of 8 whole square. Ten to the power of 8 square into 3. This must be divided by 353 square this must be divided by 353 square into pi square. 353 square into pi square. So power of 3 square is 6. So answer power 1 by 6, which is turning out to be 305.36. 305.04 mm. 305.04 mm is what I will get. Next, moving ahead for third one, that is total energy theory or Hike's theory. So total energy theory or Hike's theory is given in the data handbook, which is given by sigma yield by n whole square is equal to sigma 1 square plus sigma 2 square minus 2 times mu sigma 1 sigma 2. This is equation number 2.8e, referring to page 22 of our design data handbook. Since Poisson's ratio mu is not given for steel, you can take it as 0.3 assumed for steel. Where mu is Poisson's ratio. Poisson's ratio for steel is 0.3. We can assume suitably and solve. So if I substitute and solve for this, I will get the answer as 353 by 3 whole square is equal to 10 to the power of 8 by pi d cube whole square times 89.689 square plus 25.69 square plus 2 into 0.3 into 89.689 into 25.69. So here the diameter will be, if I solve this, I will get 89.689 square plus 25.69 square plus 2 into 0.3 into 89.689 into 25.69. This is multiplied by 10 to the power of 8 whole square, that is 10 to the power of 16. This is again multiplied by 3 square. This must be divided by 353 square into pi square. So sixth root of this will be 300.6. 300.62 mm. 300.62 mm. Moving ahead for the last one, that is fourth one, maximum normal stress theory. Maximum normal stress theory is nothing but Rankine's theory, which is maximum principal stress theory, which states that sigma max should be less than or equal to sigma yield by factor of safety, where sigma max is max of principal stresses, sigma 1 comma sigma 2 comma sigma 3. So if you observe, sigma 1 is the maximum one, because this is 89.68, this is 25.69, so sigma 1 is the maximum one, hence we will get the equation as 89.689 into 10 to the power of 8 divided by pi d cube should be equal to 353 by 3. Hence the diameter will be 89.689 into 10 to the power of 8 into 3 divided by pi into 353, cube root of answer 289.5 mm. So this is the complete solution for problem number 3, wherein which we have determined the diameter based on maximum shear stress theory, distortion energy theory, Hike's theory, and maximum principal stress theory or Rankine's theory. So this is how we should solve problem when maximum and minimum principal stresses are not given. You should find out the maximum and minimum principal stresses, that is sigma 1 and sigma 2. Once you find sigma 1 and sigma 2, then only you can jump on to theories of failure to determine the unknown. This completes our discussion on theories of failure. From next lecture, let us move ahead and start discussing on design for static strength. That's all from this lecture. Thank you all.